Hi everyone, in this lesson we will be reviewing compound interest. So the goal of the lesson is to identify and solve compound interest problems. So just to define, compound interest is money earned on both the principal and previous interest. So let's consider this example. An investment of $1,000 that earns 10% interest compounded annually. So the difference between compound interest and simple interest is that simple interest just considers interest for 1 year at a time and adds it to the amount. Compound is when the interest amount is added and recompounded in a new year, and interest is calculated upon that. So let's consider the example. So at 0 years, if we invested money, we would make 0 interest. And at the end of 0 years of investment, we would still have $1,000. But let's say we invested for a year. Okay, and here we'll be using simple interest yearly to calculate. So remember, our simple interest is P times R times T. And the amount is P plus I. So let's say we've invested for a year, so our principal amount was $1,000. Our rate is 10% divided by 100, which is 0.01 times 0.01, and we're investing yearly. Therefore, if we were to calculate this, 1,000 times 0.1 times 1 is $100. So at the end of that year, we made $100 of interest. So therefore, at the end of 1 year of investment, we have $1,100. Now, this is where compound interest is different from simple interest, is that we are going to use this $1,100 amount to be our starting value in our second year of investment. So it'll be $1,100 times our interest rate, which is 0.1, times again at 1 year. Calculate is $110 now. So now we earned in year 2 $110 of interest. So we started off in our investment year with $1,100 plus $110 of interest to have at the end of 2 years $1,210. Now this is what we will start our year 3 investment with. Our rate still being 0.1% in 1 year. Now we are calculating $121 is our interest for year 3. So at the beginning of the year, we started with $1,210 plus $121 of interest, which has earned us $101,331. We reinvest this amount in year 4. To earn us interest of $133.10. So at the end of year 4, to have a total investment amount of $1,464.10. Fortunately, we have a formula and we do not have to do countless simple interest steps. So let's understand compound interest is quoted as an annual rate with a given compounding frequency. The table below shows the number of times interest payments are compounded per year with each frequency. So let's look at the table. So we know that if we are compounding annually, our interest just compounds one time a year. If interest payments compound semi-annually, that means interest is calculated twice. Quarterly is 4 times per year. Bi-weekly is 26 times a year. Weekly, 52 weeks. And daily is 365 days. So if we look to our compounding formulas, we have 2. So our compound interest formula, A equals P times 1 plus I to all to the power of N, where A is the amount of the investment or loan, P is our principal amount, N is the number of compounding periods, and I is the interest rate per compounding period. So we'll get into some examples using those specific N and I values. We also have another formula, the present value formula, which is P equals A over 1 plus I all to the power of N. So it's just a rearranged formula of our compound interest, where that instead of solving for our final amount, we're now solving for our present value, and our amount is given to us. So let's look to example 1. So calculate the amount of your investment. Suppose you invest $2,000 for 5 years at 12% compounded annually and then compounded quarterly. So we're being asked to calculate the amount of our investment. Key word that we know that it's compound interest is that it says compounded. Simple interest won't. So we know our formula is A equals P bracket 1 plus I all to the power of N. A is what we're being asked for. Our principal amount is $2,000. I is our rate. Remember, we always need it in a decimal, so we'll divide by 100. But here we are compounding annually, so it would be divided by 1. N is our number of compounding periods. So how many times does our investment compound within 5 years? Because it is annually, 5 times 1 time a year, which is just 5. So if we substitute these values into our equation, 1 plus, oh, we didn't calculate our interest. Let's do that quickly. 12 divided by 100 divided by 1 is just 0.12. And our N value is 5. So when solving these equations, we're going to follow BEDMAS. So brackets, we have a set of brackets with an addition. So 1 plus 0.12 is 1.12 to the exponent 5. Now we're going to work with the exponent. With our calculator, 1.12, our little house to use to denote exponent, 5. Okay, we're talking about money, so keep 2 decimal places. 2,000 times 1.76 So now we can multiply 2,000 times 1.76 gets us $520. So our $2,000 after being invested for 5 years compounded at 12% annually, we will earn $3,520. So let's consider quarterly. So again, our formula, A is in question, P is 2,000. Interest is our interest rate divided by 100. This time, quarterly. So our interest is given to us with respect to a year. This time, it's quarterly, so we must divide it by 4. 4 times per year. And so the number of compounding periods. So in 1 year, if we compound 4 times, that means we'd have 4 compounding periods, but we are investing for 5 years. So we're going to do 5 times 4 is 20. So if we quickly calculate our interest, keep forgetting to do that, divided by 4 is 0.03. So we substitute our values into our formula. 1 plus 0.03, exponent of 20. Again, BEDMAS, so we simplify our brackets. So 2,000 times 1.03, all to the exponent 20. Deal with the exponent, so we can calculate that. 1.03 to the exponent 20 is 1.8. We're going to round to 1.81. We then will calculate as our final step, 2,000 times 1.81 equals $3,620. So therefore, $2,000 after 5 years being compounded quarterly at 12%, we will earn $3,620, which is pretty good. You can also compare that the more you compound within a year, the more money you'll actually earn. So let's look at